Hello. So I recently had someone reach out to me and asking about LXD and SR-IOV networking. And then I realized that even though we've got a lot of content now on YouTube and conference talks and all that stuff, we don't actually have any demo for SR-IOV networking with LXD, and especially with LXD clusters. So I figured I would just spend a bit, like a few minutes today, just with a couple of test systems I've got here to show setting up a cluster on two machines and then using SR-IOV networking for both containers and virtual machines. Before I do that, just taking a quick step back on kind of what SR-IOV is and why you'd want to use it and who might have access to that. SR-IOV stands for Single Root Input-Output Virtualization. It is effectively a PCIe feature that allows for one card to be divided into sub-virtual cards, effectively, called virtual functions. Network cards support that, some GPUs support that, there are other devices that support it. Basically, the operating system can query the number of virtual functions or slices that the card supports, and then tell the card how many of those slices it would like, and the card will then reappear on the PCI bus as having many virtual devices showing up on there. So it can be a bit funny when you look at the PCI tree, for example, because you're gonna see potentially like some of those cards do like 128 functions, and you're gonna see a massive list of them. This is supported by pretty much all high-end network cards, but it's also supported by some pretty cheap options these days, like including some of the Intel networking cards, whether they're gigabit copper or 10 gigabit copper or fiber, and then going up the stack to 25, 40, 100, 200 gigabit networking. In this particular example, I actually have two systems here. The first one here at the top is a Intel-based system. So this is a dual socket Xeon machine with a total of 24 threads on 12 cores across two sockets. It's got a bunch of memory, I think 120 gigs or so, and it's got a number of network cards because we use that machine for most of our tests. It does gigabit, 2.5 gigabit, 10 gigabit, 40 gigabit, and 100 gigabit networking with a variety of different vendors. For this demo, I'm just going to be using its 10 gigabit network card, which is currently connected to gigabit speed optic to a switch. So that's for that first machine. The second machine is an AMD-based system that's also used for both GPU and networking tests. It doesn't have a easy like gigabit or 10 gigabit SR-IOV enabled card that I can use, but it does have a dual 100 gigabit network card, which I have attached to the right network. So I'm going to be using that card. That means the first machine is going to be using Intel SR-IOV. The second machine is going to use Mellanox SR-IOV. So those are the two different systems. Before you can do any of that, even if you've got the right hardware, normally you would need to go first into the firmware, make sure that SR-IOV is enabled in your BIOS, and potentially do some more tweaks to make sure the cards will behave properly. Now, there is also a kernel side configuration that's needed. So you need to set up in the IOMMU groups on both of those systems. For that, we've got a script that we use in our lab that I'm just going to be running because that's easier. So it's those two commands, and I'll just go through what they do right after I copy paste them. All right. So the first command creates a file called etc-default grub.d99 IOMMU. That file then turns on IOMMU in pass-through mode, which is what's needed for that, and then turns specifically on both Intel IOMMU and AMD IOMMU. We do both because our lab has a mix of both vendors, and it's just easier to set both of them on everywhere. Once that's done, it runs the update grub command, which then regenerates the grub configuration file with those options passed to the Linux kernel. Once you've done that, you need to reboot. So those two machines are now gonna be going down and getting rebooted. The first one is like a full-fledged server motherboard and chip and everything, so it's gonna take a little while. The second one is more of a desktop grade type machine, so it's gonna come back up a little faster than the first. Now, while we wait for that, both of those systems are clean Ubuntu 20.04 installed. So they just come out, they were deployed through MAS in the case of this lab, but it doesn't really matter. You'll get the exact same result if you install it through the normal 20.04 installer. That comes with LXD 4 point something pre-installed, which is our 4.0 point something pre-installed, which is our long-term support release. For this demo, I'm going to be updating both of them to the current feature release, so LXD 4.17, which is going to be getting us the some of the newer configuration options we've got for SR-IOV to just make it slightly nicer when running within a cluster. The other thing worth mentioning here is this is going to be a 2 nodes cluster. This is not a recommended setup because with just 2 nodes, the database is not HA. The database will effectively just run on the first machine to be set up. The second one will get a copy of the database, but it will still need to go through the first one for all of its writes. That also means that if the first machine goes down for maintenance or reboot or anything, then the second one will not have access to the database anymore. That's why for LXD clusters, you always want at least 3 machines, which then allows for one of them to go down at any point. All right, so the AMD machine is back online. It's just going to be going on that one. And as I said, LXD is going to be pre-installed at 4.07 right now. So I'm going to be refreshing LXD over to our latest stable channel. And that's going to be downloading LXD 4.17. Then installing that. And hopefully the other machine comes back online soon and can do the same thing on it. In any case, while I'm still waiting for it, I can already run LXD init on that first system to be configured. This then asks whether we want clustering, which is the case in this particular setup. Going to be using that IP address, it's fine. We're not joining an existing cluster, we're creating a new one. The name, it just takes its local hostname by default, it's fine. No need for a password-based authentication on the cluster. We'll just be using the newer token and TLS-based authentication. So let's do that. Now, storage. I could just go with the default of using a loop device, but I do have a dedicated NVMe partition I can use, so I'm just going to be using that. Just this device. And then no remote storage, no integration with MAS, no using an existing bridge. And even though the main focus for this video is going to be on SR-IOV, I still want to set up a basic fan bridge, just so we can show the setup without SR-IOV first. And that's this system set up. Now, pretty much just waiting for the other one to come online. Said it's server hardware, and server hardware tends to spend a lot of time doing tests and stuff before actually booting up. Should be back soon though. Guess I can show that, yeah, currently there are no instances, no nothing, but it is a cluster, so it's initialized as a cluster. You can see that this is all good. I don't know exactly how long it's gonna take to come back. Just hoping just a few more seconds. Let's see if maybe it's responding of IPv4. Sometimes it does that, responding of IPv4 before v6. Nope. Come on. The other thing I can show while I'm at it is on the AMD box, the kernel command line here is going to be showing those 3 options now being passed through the change that was made earlier. That's so good. Actually wondering what's going on now with that other system. Yeah, it's taking a long time even by its standard. So hopefully it didn't get stuck. Not sure where it could have gotten stuck, huh? But oh, maybe it just got stuck in grab. That happens sometimes, and then there's a 30 seconds timeout. Maybe that's what's going on. Actually, no, I just grabbed the console on it to see what's going on. It looks like it's just stuck, shutting down or something. So I'm gonna have Maz just stop it and start it back up, which should fix that particular issue. Powering off. Okay, it is off now and powering it back on. Always with demos. Always takes it. If something's gonna go wrong, so it's gonna go wrong while I'm trying to make a demo. All right, so that system is now booting back up. It should take a tiny bit because it does need to go through firmware initialization and tests and all that stuff. And because that machine has a large number of network cards, it's taking its time usually. What else can I show on the AMD machine while that's going on? So maybe just showing the PCIe layout right now, because that's going to change a bit once SR-IOV is actually active. So as it stands, you can see this is a desktop system effectively. So it's got, compared to like an Intel server and a proper server, it's got a bit less of a flat layout. But we can see a few interesting things on there. So it does have a built-in Intel Gigabit network card. That's what's used for the main network right now. I'm not going to be touching this one. It's got some storage controller and USB all connected to that same part of the PCI bus. So that's like pretty much effectively behind the chipset. So that's like all the stuff connected to the chipset. And then there is another part here where we can see an NVIDIA GPU is directly connected. So there's an NVIDIA A100 in that system. So that's what we're seeing there. And then the 100 gigabit NIC here, which is a Mellanox ConnectX 6 DX dual 100 gigabit card. One thing that's worth mentioning there, I can show you that quickly. The Mellanox card, because it's sharing bandwidth with that NVIDIA GPU, it's going to be restricted. So for a dual 100 gigabit card to work properly, it needs 250 gigabit of bandwidth of PCI, which is what we're seeing here. It would need a by 16 link PCIe Gen 4. Because it's sharing, it's only getting PCIe Gen 4 by 8, which limits it to 126 gigabit per second. The result of that is the maximum bandwidth we're going to be able to get within that card. So like instance to instance is going to be in the neighborhood of 50 to 60 gigabit. It's not going to be able to get all the way to 100 gigabit because there's just not enough bandwidth at the PCI level. All right, the Intel system is now back up, and I can't remember if I already refreshed the snap. I did not. So I'm gonna be switching the snap on it to also run on our latest feature release. It's gonna go on 4.17. You can do it. There we go, it's done running. And we are on 4.17. So now I can run LXD init, and on the existing on the first server that got clustered, I can do LXD cluster add there. That generates a token that can then be used to cluster. I wanted to use its IPv4 address instead of its IPv6 address. I'm just going to be entering that by hand in that question. And then joining LXD cluster, yes. And I can just copy paste the token right there. Say yes. And then I will also use that same a fast NVMe drive for storage on that server too. So I can enter that here, the name it can pick. So just no need to override that. And we're done. So now got a cluster with 2 systems in it. Everything is fully operational. So let's just start a couple of containers to start with. So Ubuntu 2004, create a container called C1. The LXD cluster balances the load kind of automatically just based on which machine is running the fewest instances. So we can see the first one will most likely have gone onto Argos. The second one is now being transferred and will go onto Lantea most likely. Yep. So we can see Argos, Lantea. That's using the built-in fan-based overlay networking. So even though they're on two different systems, they can ping each other and just work out of the box. But at this point, there is no SR-IOV or anything involved yet. The next step is going to be just creating virtual machines. So still Ubuntu 20.04, I'm going to create 2 of them as well, 1 on each system. That's a different image, which is quite a bit larger because it's a full-on virtual machine. And that's going to get us 2 containers, 2 virtual machines, all on the overlay network, no SR-IOV. Then can configure SR-IOV and start spawning a few containers and virtual machines on that and just show how that works. That also takes a bit longer to unpack because the VM is in different format. It's in QEMU, QCAR2, and that needs to be unpacked onto the physical, well, onto the ZFS dataset in this case that got created for it. This is always slow for the first one. Creating additional virtual machines or containers on the same system is then very fast because we can just copy this. Sadly, because I'm literally doing 1 container and 1 virtual machine per system, it's pretty slow because right now V1 probably got onto Argos and V2 needs to go onto Lantea. So it's now on Lantea to actually go and unpack that VM into a ZFS dataset. The other thing I can show is because they're clustered, you can run the commands on either one of them, it's fine. So I can use LXD list on this one. And we can see our 2 containers and now the first virtual machine all running. I can get a shell in the virtual machine. So that's V1 on Argos that I'm in. So it's running on the other machine. And now, I don't know, let's ping C2 on Lantea. And it works just fine. Should be getting close to having that second VM now starting. Then we can go and define a SR-IOV based network. So as I mentioned, I'm going to be using Intel SR-IOV on the first machine. So that's going to be using a NIC at ENP 10.0, I believe. And another one, we're going to be using Mellanox at ENP 5.0F0. It's a dual port card, I'm just using the first port. So that should work fine. The second VM is now running. So I should say, yep, no surprises, got an IP address, everything's fine. For SR-IOV, what we're going to be doing is create a new network. So right now, if we list the networks, we can see all the physical NICs on that system, as well as a bridge here. And one defined network that's marked as being managed inside LXD, and that's the fan bridge. So that's the overlay we're using right now. I'm going to be creating a new network called lab SR-IOV. It's going to be of type SR-IOV. The parent device on the first system, so on Lantea, is ENP 10.0. I need to tell it which system it's on. So this one's for Lantea. And then for Argos, the equivalent device is going to be ENP 9.0F0. So that accounts for systems having different setup, where the NIC is not at the exact same position with the same name. Once all of the machines have their machine-specific details filled in this case the parent, then you can do a final create without any targeting, without anything, which will just create and define the device in like cluster-wide. So now for the network list, there's a new lab SR-IOV device here that now shows up. Let's start with just containers. So let's do LXD launch, images, 2004, and what were we at for containers? Got C1, C2, so let's do C3 and attach it to lab SR-IOV. This is gonna take a little while. The reason why it takes a while is because the first time we use SR-IOV on a given NIC, it needs to actually go and configure that NIC to get split into all of its virtual functions. And I suspect that C3 is going on to Argos, and Argos has network cards that are capable of 128 slices, so VFs. per port. And that means it's now creating a lot of devices. We can kind of see that if we keep running the message to see the kernel output. We just see devices after devices after devices showing up. Once it's done, it's done. We can create as many instances as we want, as fast as we want, and it will work just fine. But the initial one takes a little while. Okay, it's done now. Now let's do C4. C4 should go onto Lantea, which is Intel-based SR-IOV, and that card I think can just do 16 slices, so it's going to go much faster at getting its initial config. Alright, so I did that now. Let's see if everything's working. And looks like it mostly is. There was one thing I wasn't super sure about the behavior for C3. Let's see if it works. No, it doesn't. Alright, let me stop C3 and change one thing, because it's a dual port card, as I mentioned, on the system, and I don't remember which one of the two ports is configured properly. It looks like the port I used, which is ENP980F0, is not the correct one, so I'm just going to be changing that configuration. So it's lab SR-IOV it's called, and what I need to change is the parent, and that needs to move to F1. So that's the secondary port on it. Okay, so that's changed, and that should be all it takes. If I just start the container backup, it should now take a while because it's now it's got to go and do SR-IOV setup on the second port of that same NIC. So we're getting another 128, 27 or 28 devices showing up on the system. But hopefully the secondary port on the NIC is the one that behaves properly. The first one apparently behaved just enough to do broadcast traffic, like DHCP, but not enough to get actual network connectivity. That's just a bit a weird quirk of that particular lab. Like, as said, we use it for testing, and that also includes testing like broken and less ideal setup. So that's why that first port is not correct right now. In the meantime, we can just go on to C4 and just make sure that this one works properly. Yep. And I've been installing iPerf to do a quick test of network traffic between the two. And because SR-IOV, like, well, in some cases, well, actually, between C3 and C4, we're going to be capped at gigabit speed because the SR-IOV on the Intel system is going to a gigabit switch, and so we'll not be able to reach the 100 gigabit speed that's capable, that the other one is capable of. But after, I'd like to do Mellanox to Mellanox on that second system and see if we can get close to that 60 gigabit. And for that, we're going to need to run multiple iPerf streams in parallel, and to get the accumulated bandwidth, as like a single process just can't actually push that much traffic. At least not on that particular CPU. I'm sure there are proper servers that can do it just fine. Alrighty, so C3 is now started, and it did get V4 and V6, which is a good sign. It means it should have working connectivity. I don't make typos. Seriously? Okay, there we go. So it's also install iPerf and then just confirm that we're getting that gigabit speed between the two, and not really anything more than that. Or that would be quite surprising. 16.192. Yeah, that's your typical exactly gigabit speed between the two. So there's no big surprises. Reverse speed should also be gigabit. Yep, all good. So let's do another container, which should be placed on the same machine as C3, just a different virtual function on the same card. And then between those two is going to be more interesting as far as throughput. Okay, it's operational. Just going to be installing both iPerf and fstart. And I'm going to need another shell on this machine. I'm going to have to run multiple iPerf processes at the same time. And that means the output on those screens is not going to be very readable. So I'm running fstat on top of that to get accurate throughput information. The one catch with fstat is that if you exceed 10 gigabit speed, it starts showing it in power of 10, which is a bit annoying, like to read, but it's gonna be okay. Alrighty, so on this one, what's the IP address for it? Okay, and I'm gonna be running IPv3 server on port 1000, and then again on 1001, and then again on 1002. Okay, and then from this one, what I'm going to be doing is a small loop which does all 3 ports. IPv3 client towards 172.17.16.42, and then on the port, and run that in the background and run. All right, and we're seeing we're doing 6.77 gigabit per second was the peak. Oh, actually, no, there was a peak at 7 somehow, 8 even. Wow, okay, so that went actually faster than expected. But in average, that's probably because of buffering and whatnot. In practice, we got 3 streams at 20 to 21 gigabit per second, which lines up with the PCIe bandwidth that's available, which is 120 gigabit, but split between both ports. So we end up with quite a bit less than that, around 60-ish per port. So that makes sense. That's all good. Can do it reverse to just make sure that it's doing the maximum amount of bandwidth possible both directions. And yeah, once again, we're getting 6 point something gigabit. And yeah, same result. So that's all good. That was all containers at this point, no virtual machines. So let's do virtual machines. I'm gonna be launching, so let's do v3, v4, and do --vm, so get virtual machine. Okay, as I said, once the image actually exists, it's very quick to start. Also very quick to start once you already have SR-IOV set up on the network card. It just takes like maybe an extra second compared to no SR-IOV, and that's with all of the logic needed to go and configure that PCI device. That's really good. Just gonna give it a few seconds to boot up. Then in those VMs, we can kind of go look at the PCI setup and just show what that looks like and do a quick test. First, I'll go in one of the existing VMs, so that's V1. That one is not using SR-IOV, and we can actually see that quite nicely on the PCI bus. So if we look for Ethernet, I'm gonna see Ethernet controller, Red Hat, VirtIO network device. So it's VirtIO net, and it's no SR-IOV, no nothing, it's just virtualized networking. Now v3 should be up. Let's install PCI utils again. And I think v3 would probably have landed on Argos. Let's see. No, v3 is on land here. Okay, so the same exercise here. We'll show that we've got an Intel controller virtual function. And now if I do the exact same thing on v4, which is on Argos, and this PCI, this one shows Mellanox virtual function. So that's obviously what the main difference with SR-IOV is, that it's not a virtualized network card anymore. It is a virtual function of a physical card, so you can totally tell what card you actually have on the physical system, and you get a tiny slice of that passed into the guest. So we can try between v3 and like an hyperv server running on one of the others, but that's gonna be capped at gigabit speed, obviously, since that one is on the Intel system with the slower Intel network card. Let's take a container. It doesn't really matter. Let's take this one. So if I do 172.16.242, it should do, yeah, exactly gigabit speed. Same thing as from the container earlier. So no surprises there. Now if we do it from v4, so that's on a VM that's got the Mellanox virtual function instead. Oops, I was hoping I had the IP in my copy paste buffer, but apparently I do not. What was the IP address? This one. Okay, did I mess up? Yeah, apparently I messed up. Okay. So there we're getting single stream around 40 gigabit-ish. If we do multi-stream, we should be getting the same result as earlier. Just don't remember what container I used. Was it this one? No. Is it... What else do I have on Argos again? C3 might have been the one that they... Oh, I think C5 was actually the one that did the listeners. Yes. Okay. Oh, they're already listening. Okay. So I guess I don't have to do that. So I just need to do the client loop, which is what I had on C3. Yeah, let's try this guy here, see what that does. Yeah, so that doesn't work as well in VMs as it does in containers, which is kind of ironic. Like you'd sometimes think that a virtual machine, because it's getting a full PCIe device, that it's gonna get a better throughput, maybe. It's got like than a container, and it doesn't, because virtual machines need to actually get more CPU cores and queues and everything to deal with that, whereas containers, even if they've got the same kind of resource limits in place, the kernel is still shared, and the kernel can actually go and fill all the queues. So in this case, I think if we stop that VM, because like the throughput here was around 18 gigabit-ish, which is not that good. We're gonna be bumping the CPU to have 8 vCPUs. And try again without. I think there's also one of the listeners didn't actually work, so that's also kind of part of it. Let me go back in C5 and just clean that up while the VM is restarting. Yeah, and all 3 of them are here, so not sure why that work. So let's do 1000, 1001, 1002. Okay, so all 3 are back. Getting back in the VM and running the for loop. Yeah, that's a bit better. It's getting 5 point something, 5.47. So that's 54 gigabit per second. And we see that the per stream average is like around 15 gigabit. So it's better, but it's not quite as good as the containers yet. Don't know exactly how many more I can give. Don't know. Let's shut down that VM, and I think 12 will be the maximum. I'm kind of hoping that. I don't actually remember exactly what the specs are on this physical machine. Okay, and that's booting up, so I guess 12 is fine. I think at this point it's pretty much as much CPU as the entire physical machine has, so hopefully there's enough queues. Let's try it again. Okay, did slightly better. We see it reaching around the 20 gigabit here and there, so it might do slightly better overall, but not by a whole lot. Yeah, 5.65-ish. I mean, that kind of echoes what we've seen in many cases, that it's actually pretty difficult to get a virtual machine to reach towards that 100 gigabit per second mark, like without having to do significant work around specific core pinning, also switching, like if it's coming from memory, switching over to doing huge pages, like just being very clever around the VM configuration to manage to get as much throughput as possible. But as we've seen, like a container on that exact same system, running the exact same command can outperform it pretty easily. Actually, I think I'm running it from the wrong container, but yeah, I am. Because I'm running it from C5 to C5, so it's running onto itself. If I'm running from C3 to C5, there we go. Yeah, the throughput. It's actually kind of funny. I wonder if the card got hot, because we were getting slightly better throughput earlier. Like earlier I was doing inside the 60 gigabit plus, and now we just touched 60 gigabit towards the end. So it could also be that the physical card is getting a bit toasty, like it's quite hot here today, and that does cause performance to degrade. But in general, that was really showing you LXD and SR-IOV and some of those fast networking options. The current record we have, I think, is 85 or 90-ish gigabit per second between 2 containers on SR-IOV with that card. when there's no NVIDIA GPU eating half of its bandwidth. And the rest, yeah, it really works quite nicely inside LXD. Like we can see, if I go back, do the full listing. You can see we've got a mix of containers, virtual machines, some running on top of a virtualized network, and some of them running on SR-IOV networking. Those running on SR-IOV are getting addresses directly from the physical network. LXD is not involved at all with IP management or any of that. And you can use SR-IOV, some of the SR-IOV advanced features within LXD, like forcing the card to tag all of the packets in and out of a particular virtual function to a specific VLAN, and also doing MAC address spoofing protection. When you're on a system with SR-IOV, you can also do the IP link list, and you're going to be able to see the physical card and then all of the virtual functions underneath it, showing. Yeah, it doesn't necessarily tell you which ones are in use. In this case, we can kind of guess it because the spoof protection is off in LXD. So those two are used directly, probably by virtual machines, whilst the rest some might be used by containers, some are just unused. On the Mellanox side, things look a bit different because they don't have MAC addresses by default on the NEX. So that's the first port that didn't end up using. The second one, again, we can see one of them has a MAC address set, the others don't. But yeah, that's LXD with SR-IOV within the LXD cluster, and just showing how this stuff works well, and it gets you quite amazing throughput without a lot of the overhead of going through the host and a lot of the potential issues as well. So I hope that was useful. You can get some of that hardware reasonably easily if you've got good workstation or even like high quality desktop machines. You can use that directly in those. Otherwise, this is primarily used in servers. But yeah, hope you like that, and thanks.